Rahim, June 12, 41, reading question number 6. And we have mentioned here, I wrote everything, mass is given 0.6, here PQ. So into 10, you know very well, it becomes 6 newtons. Sorry, this becomes 4. The 4 newtons. So this is very clear, 4 sine theta. Okay, this mass is given by P is 0.6 is 6. This is 6 sine theta. And this is tension towards pulley, clear. And because smooth both, so friction is not there, I will not make any R component. Okay, the situation is what here? He says in the beginning that find tension acceleration both. Okay, 5-mark question. So let's talk about, because the heavy particle is this, so it will move this way. So motion is this way. And this lighter particle, it will go up. Okay, because there's a 6 and 4. So it's clear. So let's make it for P. So for P, what situation we have? Net force equal to MA. Net force equal to MA. Because it's going downward, so this is bigger force. So 6 sine theta minus tension equal to MA. And sine theta is 0.8. So this becomes 4.8 minus tension equal to 0.6A. Equation 1 over. Now talk about Q. So Q, it is going upward. So this is bigger. So net force equal to MA. So tension minus weight component is equal to MA. So sine theta again 0.8 here. So 3.2 equal to 0.4A. Equation 2 ready. If I just add them, tension will cancel. So 1 plus 2 add. When I add, so this minus this, we got a 1.6. And here becomes A. So A becomes 1.6 meter per second square. Okay. So this is clear. So if I put this value in any equation and get answer easily. So when I put in 2 or put in 2. So put in 2. So put in 2. So tension equal to 0.4 times to 1.6. And this add. So plus 3.2. So 0.4 into 1.6 and plus 3.2. So answer is coming 3.84 newtons. This first part is very, very clear. So let's go for part number 2, which is a little tricky. Okay. Why a little bit hard here? Because in this part we have to work with inertia, motion due to inertia. He says here the speed P reach the ground is 2. So it means it is traveling down and down and down, reach the ground at speed of 2. And you know that because they move at the same speed. They move at the same speed and same acceleration until it hits. So it hits the ground with 2. So it will reach here with speed of 2. So I just show diagram once again. So what is the whole situation here? So this particle is starting from here and traveling and hit the earth here. And this particle start from here, it goes here. This is a situation we have, okay? Let's say it start from here somewhere, okay? And this distance equal to each other. Last speed at this moment is 2, and it will not stop here. It will go slightly up and stop here. So this, I can say here very clearly that this is called motion due to inertia. Motion due to inertia. Motion due to inertia. Okay, so it means that, look, they start from here, speed 0. So they're traveling same speed, same acceleration, reach here. So here's speed 2, here's speed 2. But this is final speed become initial speed. So here u is equal to 2 and v also 2. Okay, last speed is confirmed 0 while going upward. Okay, and this acceleration is same. So let's see what happens then. So acceleration we have 1.6. Okay, so this acceleration we have. But I think we have, what is the question is asking? Find out the total time for the instant when the particle release until Q reaches the greatest height above the ground. Repeat my words. Find the time for the instant, like stopwatch start when they release. So 2 times we have to find. This time plus this time. until it is a maximum height. Clear? So I have to find two time. This time and this time same. What is here? U0. Okay, and what is acceleration here? We have it. We have 1.6. Okay, so let's see if we can find. So I talk about this particle Q. So particle Q. I'm writing here particle Q stage 1. Stage 1 or step 1 or stage 1, no problem. Stage number 1. This is stage 1. U0, last speed 2, acceleration 1.6, and my question to find time. V equal to U plus AT. Last speed is 0, U is a 2, so U0. Last speed is 2 and acceleration 1.6. So T is 2 by 1.6. 1. So 1.25 second. It means this time is 1.2 second. Now only one part left and question inshallah finish. This one. So I give a heading here for Q. Stage 2. Which stage 2? Stage 2 which due to inertia. So data what data writing? U, this V becomes U. And last speed is 0. And time is my actual question, but problem, do I acceleration? No. It means if I get my acceleration, I get my answer. So now you recall, I taught you this kind of question, what technique we have. Let's talk about this one. So situation is this, when this particle was going upward, so this is called, this is called tension. Tension, here weight component. So I will make here tension, and downward is weight component is a force sine theta. Okay, according to rule, I can say net force equal to MA. Okay, so when it hits, this becomes string becomes slack, loose. So tension becomes 0. So tension becomes 0. Actual formula tension minus force sine theta equal to MA. But tension becomes 0, and force sine theta is given here 0.8. So this is a 3.2, and mass given here 0.4. And it goes down, acceleration becomes minus 8 meter per second square. This is a turning point. This is a turning point. And question finished now. So we can say that V is equal to U plus AT. Last speed is 0, U is 2, acceleration negative 8, time is question. So 8 time is equal to 2 by 8. I got a 1 by 4. So total time is very clear. Total time is coming 1 by 4 and plus this time 1.25. So 0.25 plus 1.25. So it becomes 1.50. 1.5 seconds. So I think I got the same answer, clear? And I recall again what is the whole story. When it will hit, what the situation becomes. This becomes situation. Attentive please. When this hit here hit. So this will reach here and this string become what? String become loose. So tension will gone. So this will, here important sentence here tension is equal to 0. This is the most important point of the topic. Okay, and that's it.